Yeah, good evening to all. This is Dr. S. Magibalan, Mechanical Engineering Department. Now we view a topic of heat and mass transfer. Within a heat transfer, there's a three type of heat transfer: natural convection, conduction, radiation. There is a three mode of heat transfer: conduction, convection, radiation. Now we move on convection. This is a convection type. Uh, why I given this video for this modality? This is a help of virtual. We know about how it's working for in a virtual mode. There is a difference of material, aluminum, copper. If I change for the material, the material is changed like iron and then silver, steel, so you vary the material by you go for an experimental mode. You will have only one material. In that material, you calculate for an heat transfer and Nusselt number. In this medium, there is an aluminum. You will varying that values for 5 to 10, and then same height also there is a 70 to 80, and the dia of the cylinder 4 to 10, and then length 50 to 60. You will what I changing the virtually you will also view that the changes. Then cylinder thickness. Now I restart those things for a common parameters. I taken a standard value of those. Just I kick off for a power on. How it's reacting. The natural source is taken the air. It's react with the T1, T2, T3, T4, T5, T6. That reading is calculated voltage and then ammeter. The heater source is on and off. The power source, and then T1. Again, you move for T2, T3, T4, T5, T6. This is the experimental purpose. Now we move for an A. What is the T1? The value. After that, you will show for a cross-sectional view. That cross-section, how it's working. This is a heating coil, and then this is the result for H, and then Nusselt N. Similar that you will restart those the experiment, and you will choose for another one material like copper. This is a copper material. Again, you will change that varying values in this virtual mode of data. You will want to vary that material dimensioning, and then with the height and then parameters. Now I on for the experiment how it's reacting. Again, it's showing for the H and Nusselt values. So similar kind of activities you will notice for all the chosen material, silver and then steel, all those things. This is one type of convection mode. It is used for a natural convection method. We deals with the natural means it is a source is air, and the naturally how the material absorb the heats and how it's reacted. All those parameters discussed in that spot is very easy once you visualize those things for an virtual mode. Then you go for an experimental purpose. You want to invest to work out those things in a experimental method. It is very useful for those things. Next, we move on. This is for conduction. The thermal conductivity apparatus to slab guarded hot plate. Now I vary the materials, cardboard, glass, mica. All those materials you will change for a material. What that? That is a dia. You will change for a dia, and then thickness, and then cold water. There is a two water source. One is cold water and there is hot water. If the cold water is inside here, and then the heat is absorbed for, and it is taken out. Now you start for this experiment with the help of this, and You will measure that values, thermal conductivity. I restart and go for an glass. If the material is on glass, I will choose for an random values and I on that power show that results. This is the thermal conductivity. Same manner you will calculate for other than materials like mica. You will choose any other intermediate values and start that experiment. It is very useful to how that react, and finally what we calculate all those things here itself you will know. So I will start this thing. Now I move for radiations. In those emissivity measurement, apparatus is a radiations. One is gray and one is black body. The setup is T1, T2, T3, and there is a source T4, and then T5, T6, and T7. Same here also there is a material like aluminum, brass, and then iron, and silver, and copper. Now I chosen for aluminum. The materials change for aluminum. This is, and now I choose for a brass. This is a brass material, and iron. This is iron material. This is for steel material. This is a copper material. Now I run for any diameter of the plate. I vary for 7 and thickness and the chamber temperatures. Now I start the experiment. It is started, and now I measure the results. This plate is 0.78. Now I restart and I pick for an brass material, or else you go for an iron material. You pick for intermediate values and start that experiment and view the results. This is the plate. This is the plate MCT plate value. So this type of learnings is nowadays required. Why? Because we change for a material, uh, different materials, and we will upload those values with the help of virtual. Then it is very easy to incorporate our knowledge level in next level of learning. It is the ICT and tools. So I share these things with you. There is any number of sources available in a virtual labs. You will focus on a virtual lab for an lecture concepts with an experimental works. All those things is available for any number of virtual labs. You will visualize the things and go for an experimental. It is worthy one to convert that your learning level is for next. So I happy to conclude this basic one for an heat transfer conducting radiation within a coverage of what is that virtual how we change for an internal parameters with the help of that material parameters also within a different type of material with the three experiments. Mm, I happy to conclude this short things for an quick learning and how you use for an nowadays virtual things with your daily concepts. It is very use and it is very easy to understand how it's working. What are the points we need to learn? All these things are clearly given in that parameter itself. I hope this is the one video for starting that students going for a virtual things. Then it is very easy to understand. I continuously put on a videos with a different subjects, different aspects. Thank you for all. Thank you for this time.